So here we're going to talk about isomorphism between two graphs. Okay, so for we have to know that if you have given two graphs g v comma e, g dash v dash comma e dash, these graphs are said to be isomorphic if they are one-to-one correspondence. If there is a one-to-one correspondence between their vertices and between their edges. Now what do we mean by one-to-one correspondence, and how do we find if two graphs are isomorphic is what we are going to understand right now. So the isomorphic graph have these things, that is they will be having the same number of vertices, they will be having the same number of vertices and edges, and also they have the same number of vertices with a given degree. That is, if I have a vertex with 2 degree 2 for in one graph, then I have to have a vertex with degree 2 in another the other graph also. That is how the number of vertices with a given degree, they should have the same number of vertices in two graphs, in both of the graph. Understood? And also, if all these conditions are satisfied, then the next condition we have to check is adjacency condition. Adjacency condition, if there is one-to-one correspondence, that is adjacency. So how do we do this is, let's start with this one example here. You have two graphs g1 and g2. So here if you see the number of vertices, first let's see the number of vertices here. So first let us see number of v here, vertices here. Here if you see a, b, c, d, e, there are 5 vertices. Fine. Here now check here also. Here if you see v1, v2, v3, v4, v5. So here also the number of vertices is 5. Fine. Now next thing, next check the number of edges here. Here if you see the number of edges is 1. So there is 1, 2, 3, 4, 5 and 6 edges are there. Here if you see the number of edges, here e1, e2, e3, e4, e5, e6, e6. Now both of this two condition has been satisfied. Now here let's see the vertices, each of these vertices degree. Degree of A let us find first. Degree of A is 1, 2, 3. Okay, that is 3 is the degree of A. Then let's find the degree of B. 2 edges are there in B, so there is 2. Now let's find the degree of C. C if you see 1, 2, 3, right? So there is 3. Now let's see the degree of D. D if you see 1, 2, 3. 3 is the degree of D. 1, 2, 3. Now E. E if you see, it is only 1. Fine. Now here if you see, here in this side if you see the degree with degree of vertex v1, let us find here. v1 has 1, 2, 3, right? So it is 3. Now degree of vertex v2 we can find now 1, 2, right? 1, 2 only is here. Now v3 if you consider 1, 2, 3. So degree of vertex v3 is 3. Fine. Now v4 1, 2, 3, 5. Degree of vertex, I can write here. Okay. Degree of vertex v3, v4 we are finding for v4, right? v4 is 3. Now v5 is 1. v5 is 1. v6, where is v? Oh, v5, only 5 is there, right? So here if you see, we have 3 vertices with degree 3. Here also 1, 2, 3. 3 vertices with degree 3. 1 vertex with degree 2. Here also 1 vertex with degree 2. Now 1 vertex with degree 1. Here also 1 vertex with degree 1. So here if you see, there is the number of vertices with the same degree is same here in both the degrees is same in both the graph. So the third condition is satisfied. Now let's do this adjacency, like one-to-one correspondence. How can you see is that here, see this vertex A degree, if you see 1 2 3 is a vertex A's degree. Fine. 1 1 2 3 is a vertex A's degree. Okay, and it is connected to B vertex 2, C vertex 3, D vertex 3. So this A is connected to 2 3 3, right? That is vertex 2, vertex 3, vertex D. So if I am saying that here, let me take one vertex with degree 3, let's say V1. Now V1 has degree 3, okay, degree 3. So if I am saying A is 1-to-1 correspondence with V1, okay, that means if there is this B which is degrees 2, then that means this V1 should be connected to one vertex with degree 2. So here if we see this V2, 1, 2, here this is 3 is what? This is 2, this is 3, V4 is what? 3. Fine. So that means V1 should connect with V2. So that means B can be what? B can be V2. This is how you have to check 1-to-1 correspondence. Okay. If all these conditions are satisfied, it is clear that it can be isomorphic. Fine, but we have to check adjacency also. So in order to do that, we have to write the vertex of all these degrees. This is 1, this is 1, and we have to see if in here the vertex with degree 3 is connected to 2 3 3, then here also the vertex with degree 2 should be connected to one vertex with degree 2, one vertex with degree 3, and one vertex with degree 3. So here if I am saying this B and V2 are same, and if this B is connected to A as well as, that is if this AB, see AB is connected, then that means V1 and V2 should also be connected. If I am saying that in this graph AB is connected, then in the other graph I said that A is can be V1 and B can be V2, then V1 and V2 is also should be connected, which you can see it is connected. Now let's say this C, okay, let me say that the C is connected to A as well as the C is connected to B with 2. So that means with AC and BC also there is a connection with, now A has a connection with C and similarly B has a connection with C. So that means V1 should has a connection with one vertex here and V2 should also have. So V1 is here, V2 is here. Now what is the degree which is both connected to both this? V1 is connected to V4 and V3 and V2. V2 is connected to V3 and V4. Common is what? V3. So I can say C can be V3 because its vertex is also 3. Here C's degree is also 3. Here also the V3's degree is also 3. And V1, like A is connected to C and B is connected to C. V1 is connected to V2. V1 is also connected to V3 and V2 is also connected to V3. So I can just say it can be the same. Now let's say D. D has a degree 3, but it should be connected to one vertex which is having degree 1. That is this. This vertex has degree 1. So D can be V4 because D is here. D's degree is 3. V4's degree is 3. But D is connected to one vertex, let's say this E, which is having degree 1. So here only V4 is connected to one vertex with degree 1. So D can be V4 in here. So now rest is what? A, B, C, D, E. So finally E can be V5, like that. Here you have to write this 1-to-1 correspondence like this. See, if you see 1 can be E1, right? See, not here, A, B, C, D, E, F. Not, this is the, okay, here this is the vertex. Now I have to write this vertex correspondence here. This is the correspondence of vertex. Similarly, we will be having the correspondence with edges also. So this how we have done by looking at the graph. If I am having a vertex with degree 3 which is connected to a vertex with degree 2, 3 and 3, in the other graph I should have a vertex that can connect to degree 2, 3 and 3. Like that we have to check. If this vertex is connected to a vertex, now here if you see this vertex is connected to a vertex here with degree 1, then in another graph also I need to find a vertex, that is V3, which is connected to vertex which is having degree 1. Like this how we will find the 1-to-1 correspondence. Okay. Now let's see this question, okay, and see how can you find a similar answer in this question also. Here if you see, this is a non-isomorphic. How? Let's find out. Here let's say this is V1, this is V2, this is V3, this is V4 I will say, V5 I will say this, V6 I will say this. Now this I will say as 1, 2, 3, 4, 5, 6 I will say. Now all have 6 vertices, here also 6 vertices. Now edges is what? 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Number of edges is also same. But here if you see the degree of each of this, degree of V1 if I am finding it is what? 1. Degree of V2, V2 is connected to this edge also, this edge also, so that is 2. Degree of V3 if I am finding, I am having V3's degree as 1, 2, so that is 2. Now degree of V4, V4 if you see 1, 2, 3, right, so 3. Degree of V5 is 1, only one edge is there, and degree of V6 is also 1. This is for this graph. Now if you find for this graph, degree for 1, vertex 1 is what? 1. Now degree for vertex 2 is, if you consider this vertex it is 1, 2. Now degree for vertex 3, that is for this vertex if you consider 1, 2, 3, it is 3. Okay. Now degree for 4, degree for 4 means if I am considering for this vertex it is 1, 2. Okay. Now degree for 5, vertex 5, that is for this vertex if you consider it is 1. So here if you see degree of 1 is 1, 2, 3. Here if you see 1, 2, degree of 6 I didn't find. It is 1, 2, 3. So 1 number of vertices with 1 is same here, 3, 3. Now with 2, here it is 1, 2. Here it is 1, 2. So that is also same. With 3, it is this. So that is same. So here if you see, the number of vertices with the same degree is same. So if it is that case, if you see this image, let's do the correspondence now and see if it works. The adjacency would be wrong here. I will show you how the adjacency is wrong. We can't draw a one-to-one correspondence here. See, if you see the vertex, okay, this vertex 3, vertex with the degree 3 is connected to vertex with 1, degree 1, 1 and degree 2. Here this is a vertex with degree 3. This is connected to vertex with degree 1, and this has a degree 2 and this has a degree 2. I told you this vertex with degree 3, if it is in this graph, is connected to vertex with degree 1 and vertex with degree 1 and 2. Here also should be connected with the vertex with degree 1, 1 and 2. But here if you see, this vertex with degree 3 is connected to vertex 1, 2 and 2, not with another 1. So this is not one-to-one correspondence vertex. So therefore we cannot say it is isomorphic. Though all the conditions are satisfied, when we check the adjacency, it is not satisfied here. So one important thing, that after checking all these 3 conditions, you have to check the adjacency also. Okay. Now let's see for this graph. Here if you see for this graph, the number of vertices here, I think I need to draw this graph in the other page. 1 minute guys. Okay. Let's go on there. Fine. Okay. Now here if you see, I have to show one-to-one. First I wanted to show that, like the other case itself, I want to show that this graph is isomorphic, these 2 graphs which is given here. So let's see how we are going to show that. So here if you see, there are 2 graphs here. The number of vertex is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is same. The number of vertex condition is satisfied. Now edges if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Both have the same number of edges. That condition is also satisfied here. Fine. So, if it is that is the case, now check here. Now what we have to do is that we have to check the vertices, that is vertices of all these. Okay. So here if you see, degree of A1 is what? 1, 2. So it is 2. Degree of A0 is this 1, 2, 3. Right, that is the degree. Now degree of A2, if you consider, it is 1, 2. 1, 2. Degree of A3, if I am considering, it is 1, 2, 3. Degree of A4, if I am considering degree of A4, it is 1, 2. Degree of A5, if I am considering, it is 1, 2. So it is 2. Fine. Now we have to go here, that is, let's consider the degree of B0. Degree of B0, if I am checking, it is 1, 2, 3. It is 3. Okay, 1, 2, 3. Right. Now B1, degree of B1, if I am looking at that, it's 1, 2. Then we have degree of B2. That is also 2 if you see. 1, 2. Right. Then you have degree of B3. B3 is 1, 2, 3. Degree of B4, if you check, it is 1, 2. Degree of B5, if you check, it is again 1, 2. Fine. So here these are the degrees. Similarly, if you check it here, like for all of these vertices, if I am checking, I can get degree of U1 to be 2, degree of U0 is 2, degree of U2 is 1, 2, 3, right? So it is 3. Degree of U3 is 1, 2, 3. Okay. Degree of U4, if you check, it is 1, 2. Degree of U5, if I am finding out that, it is 1, 2. Now degree of V0, right, that is here, this is degree of V0 is 1, 2. Degree of V1, if I am considering, it is 1, 2 again. I don't have place, right? Degree of V1. Now I am writing here V2. V2's degree as 1, 2, 3. It is V3 is 2, 3. 1, 2, 3 is V3. V4 is 1, 2. V5 is 1, 2, 5. So here if you see, the number of vertices with degree 2 in this graph is 1, 2, 3, 4, 5, 6, 7, 8. And in this graph it is 1, 2, 3, 4, 5, 6, 7, 8. Both the degree with vertex 2 is same in both the graph. Now let's count 3. 1, 2, 3, 4. Here if you see 1, 2, 3, 4. So the number of vertices with this degree is same here. Now we have to check the condition of adjacency. Here if you see, this vertex here, this vertex has what? This vertex has degree 3. Now this vertex with degrees 3 is connected to this vertex with degree 2, and this vertex with degree 2, and this vertex with degree 3. So vertex 3 should be connected with the vertex with degree 2, vertex with degree 2, and vertex with degree 3. Here this is one vertex with degree 3. Like inner, this is also degree 3, this is also degree 3. Okay, this vertex has degree 3. So that means this vertex should be 2, but here this vertex is degree 3. This is 2, this is 3. So this is 2 here and this is 3. Here you have 2 here in B2, but here you have 3. So that means they are not adjacent. There is no one-to-one correspondency. You cannot write for whatever pairs if you take in both the cases. So if there is no adjacency, that means these two graphs are not isomorphic. That is, these two graphs are not isomorphic here if they are not one-to-one correspondent. Similarly, if you find for this graph here, let's find for this graph. The number of vertices here is what? A, 1, 2, 3, 4, 5, 6, 7, 8. Here if you see 1, 2, 3, 4, 5, 6, 7, 8. Both are same. Adjust 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is there anything I left? 12 here. Okay, fine. So 12 edges is there. Okay, so that condition is satisfied. Now let's find the degree of all the vertex and whether we can create a one-to-one correspondence here. Then we have to see whether we can create a one-to-one correspondence here. Let's see that. So here if you see degree of A, let's start with the degree of A. Degree of A is what? 1, 2, 3. Okay. Then let's find degree of B. Degree of B is 1, 2, 3 again. Degree of C is 1, 2, 3. Degree of D is 1, 2, 3. Right? 1, 2, 3. E. Degree of E, if you check, it's here. 1, 2, 3. Now, degree of E, F, 1, 2, 3. G is also 1, 2, 3. H is also 1, 2, 3. Everyone has degree 3. Here if you see L, degree, like we can start A, B, C, D, F, G, H, I, J, K, L, M, N, right? So here we start here H. If you check the degree of L here, degree of L is what? 1, 2, 3. That is 3 here. N if you check 1, 2, 3. That is also 3. O if you see 1, 2, 3. That is 3. K if you see 1, 2, 3. 3. J if you see 1, 2, 3. P you see 1, 2, 3. M 1, 2, 3. I 1, 2, 3. All have degree 3. Here also all have degree 3. Here also all have degree 3. If all have degree 3, the number of degree is same. And if I'm writing correspondence, I can write it anyway because all have the same number of degree. It won't be like this kind of issue won't come, because whenever there is different degrees like 3 and 2 mixed degrees is coming, then only these kind of issues we have to check. But here all have the same degree, so we don't need to check. If you see this vertex has degree 3, 3, 3. Here also, if any vertex is 3, they all have connected to vertex with degree 3 only, because here we have only degree 3. So they will be isomorphic. So you can write one-to-one correspondence. You can take any. If I am saying A to be I, then I can say C to be J, E to be M, C to be P. Like any way you can write the one-to-one correspondence. This is one way you can write. You can take any way. If I am saying that A is correspond like to I, then I can say C can be correspond to J, because if here you have to understand one important thing. While we are writing one-to-one correspondence, that is I will show you one way in which we can write one-to-one correspondence here. If I am saying here A is corresponds to I, then A is connected with C, B. So here if I am writing the B here next, then it should be connected with I, because A is connected with B. So one which, let's say L, I'm taking L, so that means I am taking I and L should be connected. Okay, now if I'm saying C, A is connected with C, but B should be not connected with C. So means I need to write something which is connected with I, let's say J, but it should not be connected with C, because B and C there is no connection. So that means L and J there should be no connection, so there is no connection here. But I and J there should be a connection, because here A and C has a connection. Now let's say E. Now if I'm finding out for E, A and E there is a connection, right? E there is a connection with, so let's say if I'm taking M here, let's say this M is this, M there should be no connection with only with I there should be a connection. With L and J there should be no connection, because B and C is not connected with E. So if you see J is here, L is here, there is no connection. Okay, fine. Now let's see, now let's consider B. B we have considered D. Now D should be connected, should be have a connection with C also, with B also. So that means if D is connected with C and B, C and B is L and J. So I want to find here I want to find one correspondence for D which is connected to L and J. This is L, this is J. So one vertex that should be connected with an L and J is only I, right? And also there is one vertex here K that is connected to L and J. So let's say D can be K. Why I'm taking D to be K? Because I need to find a vertex which is connected with, because we know D is connected with B and C. So that means I need to find something which is connected with L and J here. L and J here I, which we have already took to be A. So that means next I need to take it as K, because that is next connecting with this. And does K has any relationship with M? No. So we have no relationship with E for D. That is correct. Till now we are in a correct path. Now let's say for G. Now let's consider G. G has a path with C, right? C is what? J. So J, it should be connected. Let's say P. Okay, P let us say. But M also there is a connection. We have to take M to be E, which is a connection. So that is correct, because if this G has a connection with E and E's correspondence is M, then P is what having connection with M. So then we can take this. So this is correct. Okay, this correspondence we can write. Now let's find it for H. Now H has a connection with G, also H has a connection with F and D. Okay, let's say if I'm taking O, K is what? K is what? K is D. So I got H with connection with the D. That is done. Now G. G is what here? P. Do I have connection of O with P? Yes. So G is done. Now F. F is what did I take here? I didn't take any F here. So it's 5. So this is correct. Now finally I can take F to be N, because that is the only option here. So like this is how we are going to check one-to-one correspondence. Okay, this is one important thing that you have to understand. So this is about isomorphism. Thank you.